So we continue with our implementation of Quicksort algorithm in Java. So this is where we started. So let me clean up this code so that it looks a little simpler. So we say there are two functions we need to write. We have to write the Quicksort and then we need to write the partition. So we mentioned that Quicksort algorithm works by maintaining a left and a right index and a pivot, which kind of roughly means the midpoint of these two extreme these two ends of the data. So the pivot is the midpoint, meaning that on the right side of the pivot we have greater element, on the left side we have less element that is lower than the pivot. So we now have to do a partition, which is a partition function that actually partitions the array, dividing this array into two, and gives us a midpoint, a dividing point. Remember, the pivot is actually not the dividing point at this time. All right, so let's go ahead to write this partition function. So it's going to be something like this. Let's say public static. So it's going to be int because the partition function is going to return the pivot, the point at which we need to partition. So I will explain it a little more as I go. So partition. So it takes the array for sure, and it takes left, and it takes the pivots. Okay, so all right, all right. Maybe I'll make a little room here. Let me see if I could shift this. Okay, perfect. So now we have this error because it's asking of a return type, which we are going to implement a little in a minute. So the partition is actually going to work in this way, such that when this left is moving in this way and the right is moving in this way, they don't actually meet on the pivot. They meet at a point where, at that point, any element to the left is less and any element to the right is left. So the pivot can actually be here while the partition point is somewhere here. So take note that the pivot point is not the partition point. All right. All right. So let's now implement it. So what we are going to be checking, the stopping point is while left is less than right. So we are going to say while the left index left is less than or equal to right. So at this point it will terminate. So for now, while left is equal to is less than or equal to right, we are going to continue to move left one step at a time towards the right, and we are going to move right one step at a time inwards. So we are going to say while array left, so while the left element at that point, okay, is less than the pivot, okay, then we actually should not do anything. We simply increment it one more. So what we are saying in effect is, let's go back to this place. So once 2 is less than the pivot, then we don't really need to do anything. We simply move further. So that is why you can see we did not swap 2. We simply move ahead. So while array left is less than the pivot, we simply move left one step. So we simply move left one step, right? You just increment it, okay? All right. So at any point where it becomes greater than the pivot, you find the left greater than the pivot, you stop there and then go to check right. So in this case, you now say while array put something here, okay, right. This time, in the case of the element at the extreme, you are checking while it is greater than the pivot. So if it's greater than the pivot, you don't do anything, you just move on. So while it is greater than the pivot, so you just move on. So you don't have to do anything. Right, minus minus this time, okay? because you are going to decrement it. So if you come down to this place, it means that at this point we have an element that is in the left that is actually greater than the pivot, and we have an element at the right that is less than the pivot. So we need to actually do a swap. So we are going to say if we are going to swap if left is less than or equal to right. Remember that we have a while loop here. So once it comes out from these loops, we are going to swap once left is less than or equal to. Remember that if left is less than is equal to right, then you actually don't need a swap. You need to stop. Right. So or left is greater than right, you don't actually need to do anything. So I would recommend you take some time, pause the video, and try to get your head around it. So you actually swap. This is a swap function that I'll have to give it to you as an assignment to write it. So do write this swap function on your own. I'm not going to write it for you because it's really very easy to write. So you swap it. After swapping, immediately you also increment left and decrement right. So that if statement is going to catch. Once after this increment and decrement, we have this condition holds, then we don't actually need to do any swap. All right. So at the end of this while loop, let me come out from this while loop. So at the end of this while loop, it falls down from this while loop. At this point, left might be greater than right. Okay. So at this point, left is now holding the partition point because every element to the left is less than the pivot. Every element to the right is greater than the pivot. And at the partition point, it divides, is a dividing point, giving us lesser elements and greater elements. So we simply take that partition point as the partition point. So let's just return it. Remember, we are increasing left in steps. So at this point, left is going to now be the partition point where we need to partition it. So what I'm going to do, I'm going to clean up this code. I just want to prove to you that this code is really very simple. So let me just clean it up and just make it so that you'll be able to see that it's really easy. So we have, this is just the partition function. We have this. Then the quicksort function, which is a recursive function, I'm going to also clean it up a little so that you can see that it's really not really a big program. So you can see the quicksort program is really very small. So this is initial quicksort that sorts the original array before any partitioning has been done. So I'm going to stop here. So what I'm going to ask you to do is to write a main program. In fact, I'm going to a main function to test this quicksort algorithm. So you can just try a main function public static void main string args, then create an array. After creating an array, call quicksort and then see that this array is sorted. Print this array before sorting. So let me just write what you need to do. Create an array, call quicksort. Okay, print the array before sorting. Call quicksort to sort the array. Then print the array after sorting. So if you do this, then you will be able to appreciate how it works. So I'm going to stop here. I'd like to thank you for viewing. Remember to subscribe to my channel by clicking on the subscribe button. If you have any programming assignment or any coding assignment you have challenges with, just leave it for me. Write in the description box, in the comment box, and I'm going to help you solve it in a very short time.